Hello, I'm Daniel Higuereta, and this is my EE329 lab video demonstration for assignment 1. In this assignment, I was able to implement an LED counter that counts from 0 to 15 in binary, as well as take a lot of measurements on execution time, specifically for the call function latency, as well as many operation instructions. Here is my circuit, where I have 4 LEDs, 4 560 ohm resistors, and then I'm using 4 pins to be able to have my code be able to implement onto the hardware and light up these counters. I'm also using the Analog Discovery 2 from Digilent in order to use my computer as essentially an oscilloscope, where this orange probe is channel 1 and this blue probe is channel 2. So channel 1 will be measuring the least significant bit, and channel 2 will be measuring the on time for the first bit. Here is the code, where I have a while loop, and within that while loop is my LED display, where I have a for loop for it. And it calls a function that I made and I made this function for more practice called display LEDs, where it takes me down here to basically AND the value that I have and the count in this case, as well as 15, so that the LEDs will match the actual value that I have. It'll then go back to this for loop, and once it pops out, it'll increment this cycle counter. And this tells me, as well as like the code that I have in this if statement, if I have gone through 3 iterations yet. Once I have reached 3 iterations, it'll go into this if statement, reset the bits, and then stay in this forever loop right here, this infinite loop, since 1 is always true. In this loop, I will be testing the call function latency, as well as any of the operation instructions. So first we're starting with no operations occurring, just the number itself, and I have the number to be 15, as well as our variable type being unsigned integer 8-bit type. So to start running the code, we would debug, and down here it'll tell you the process as it goes through. And then you would click this play button called resume, and once you click that, it'll start counting. Okay, now that it's done counting, that means we're in the test phase. So now we can go to the waveform. We press run, and I also added cursors right here from the X cursors. And right here you can see the difference between the two, which just tells us the time that the LED has been on. So this time tells me how long it takes for the operation instruction of, in this case, it's just the number times 1, it's the number itself, to be executed within the function. And this takes about 1.8 microseconds. We could also do another operation, such as multiplying it by 3. And the quickest way to rerun it is actually doing the terminate and relaunch button. It goes through the whole debugging process once again. However, it's one button that you click, rather than having to click that, saving it again. It's downloaded successfully, so now we can relaunch it again, and it'll start counting. And we can see in this waveform that the time has increased with this operation. It is now 2.79 microseconds. Additionally, something I did not mention earlier is the time distance between when the least significant bit is on and when this first bit is on, since we turned this on just before we called the function, this difference actually tells us how long it takes for that call function to actually start working within the, like, executing the function itself. And that is around 3.44 microseconds for a call function to start executing. We could change the variable type itself using this type def. I'm going to do double. And I will keep the test variable as, or the function as the ×3. So let's relaunch this. Now that it is all good to go, I press resume. It goes through its iteration once again. I skipped the iteration just to make it a little bit faster for the video. And here we press run. And you can see that it is off the screen. So let's zoom out, press stop so we can get a singular waveform right here. And this distance is about 19.5 microseconds.